Okay, so this is how it felt like when I joined Ziprecruiter. Hundreds of millions of dollars in revenue, tens of thousands of customers, tens of millions of job seekers, operations of hundreds of salespeople, account manager, customer success, double-digit growth every year. Best data-driven company that I've ever been in. People use KPIs, A/B tests, dashboards to tell us where to invest, where to go. Data is the currency of the company. Definitely the most impressive company that I've ever been in. And the future looks exciting. But behind the scene in the control center, some concerning signals started to appear. Data production incidents took us too many days to resolve. Data analysis required too many people with too deep domain knowledge. It was really hard to launch new data projects and obviously to run several of them in parallel. Stakeholders like our CEO or sales operation didn't get their insights on time. Dashboards were broken, datasets weren't refreshed. So in this presentation, I want to cover how Ziprecruiter managed itself out of this mess. So, hello everybody, my name is Yaniv Shalev. I'm SAP Engineering in Ziprecruiter. I'm responsible for the data vision of the company and also for employer and job seeker data products. Prior to Ziprecruiter, I was the CTO of Convertro, which is a marketing analysis platform, and it was acquired by AOL, Verizon, Yahoo in 2014. And I'm highly passionate about data for more than 20 years. I did so many roles. Some of the things that the previous speaker talked about. And I have other hobbies, as you heard. And Ziprecruiter is an AI-first company. So we are running an AI-based employment marketplace, which actively connecting people to the next opportunities. We are covering all the job market. So we are covering software engineers and baristas and nursing and drivers. Just think about something. And also serving all the different segments of customers, like Fortune 500, enterprises, small and medium businesses. Just think about that more than 790 millions of application to hundreds of thousands of businesses have been done by job seeker through our systems. So here is a fun fact, okay? What do you think is the most searchable search term in our search engine? CEO. Work from home, baristas. Okay, empty searches. Like 30% of the searches are just like blank. Okay, people are relying on us just to advise them. And this is why we have to build personalized AI models. And those models are built on contextual data, which is parse resumes, and profile and job description, more contextual signals, but also on billions of daily behavioral data points. We're also running for more than 10 years, so we accumulated like petals of big, deep, rich information, which help us to get the best algorithm in our segment and improve them all the time. So we are running, we went public on May 2021. We have headquarters in North America. We're operating there. We have a representation in Europe, and also a big engineering center in Tel Aviv, which contains more than 90 engineers and data scientists. Significant amount of them are actually really good bakers, which I found that interesting. Yeah, and we are planning to hire much more people, like 50% growth in 2022. Okay, so let's go back to the question, right? The question was like how we managed to pull ourselves out of this like data swamp complexity. And obviously doing so without interfering in the business growth, without reducing the development velocity. So in order to understand that, we have to go 2.5 years ago. And I'm going to use this diagram to be less abstract about it. So back then, process-wise, we didn't have so many standardized or unified ways of doing stuff. how to build a data set, how to guarantee their quality, how to share information between different systems. Structure-wise, we used to have teams of specialists, teams of data people, teams of SREs, team of data scientists, web developer, backend. So just think about just about 10 data engineers needed to support a tech organization of more than 200 people. The knowledge and expertise on other teams was pretty low about data, so it created a lot of misuse of technology, and we didn't have best practices or standards, so every solution looked so different, every project. So we had many snowflakes. And that's create silos and islands of inconsistent and duplicative information, which result with an explosion of takeaways of data things. Can be like data snippets or data sets or business logic. And of course, that created a lot of slowness and confusion, right? Raise the data. Which business logic should be used? It was really hard to onboard new people. It was really hard to move people across teams. And it required a ton of people to actually launch a new data project. So we set together several people, data engineer and myself, and we concluded that we can actually organize all the business entities and events in something about 100 trusted, verified data set. So if we do so, everything is going to be more simpler, right? So it's going to be easy to discover the data and its feature, right? It's going to be easy to guarantee SLA and quality. It will be easy to understand who is accountable, who is the owner of the data, and who are the consumer. So we had to devise a plan of how to organize the data. And the plan should address all the different access that I showed you before. So let's start with the process first. And first thing first is to have a vision, okay? And the vision was that data and teams are going to be organized in domains instead of technological expertise. So for example, job seeker domain is going to be responsible for profile and resumes and job seeker interactions, like impressions, clicks, applies, and so on. Employer side is going to be responsible for company or listing, which are jobs, or campaigns. Each domain going to have a clear ownership on the data, the business logic, and the interface, how this data is going to be shared with other domains. And what is a business logic? Business logic is business decision as code, right? So for example, our job seeker location can be derived from the resume, this is the hometown, and then also for the job that this job seeker applied to, so we have another signal, and then also from the click event because we have the IP. What is the correct answer? It depends. Okay, so it was a fun project, by the way. Some people are sitting here, including Lambda architecture, but that's for another lecture. Let's go back to the domain. So each domain is accountable for the quality SLA of their data sets, which means data freshness and availability and duplication rate and completeness and so on. So the goal was to create a domain that will focus on their key results and will be executed with minimal dependencies on other domains. The second thing is start to treat data as product. And every product, other kind of product, they have interface, okay? So we have to invest in schema and feature design. Data is not just a byproduct of application log. It really creates opportunities and capabilities to the business. And also, every product has guarantees, so we need to make sure that quality and SLA are continuously validated and monitored. So this is why we invested in making sure that data sets are ready on time, or how many bots we have in the system, or classifying scammers, or smart and proactive PagerDuty alerts, or data quality methodology and building frameworks that are going to be integrated into our pipelines. As in other products, we have to measure the impact on the business KPIs in order to prove our investment. So data products should be part of the OKR process. We define goals that will help to prove the investment and also will gear easier collaboration and cross-team prioritization. So one of the biggest achievements that we had is investing in one of our job seeker datasets, which improved our matching algorithm by more than 22%. And the last thing is a really good and defined development data process, development lifecycle, and here's a data development lifecycle, which means we want to have really good process that help the team to be unified about how they are building their data product. And that means first, really good understanding of how to design data product, which means like focusing the engineer on gathering requirement and schema design and data flow, but also investing in data QA methodology and testing and how we want to do deploy and how we want to document things, how we are dealing with bugs, how we're dealing with backfills, how we're managing production incidents. All of them are part with all the life cycle of every product. And most importantly, we trained our product managers and tech leads to help to enforce this process. Another thing that we've done is segmenting the data into guarantees ponds. So it will be easier to understand which data set should live where, right? So the operational pond, this is where data from operational systems are just being dumped into a durable place. And its schema is pretty operational. It quite resembles the source systems and operational system that created it. So the data is not verified, probably have many duplications in it, and probably should have like one job or process that takes this data and start to rebuild it to much more read-optimized way. The exploratory point, this is like a staging area. This is where you're starting to clean the data. This is where you're trying to start to enrich the data with all kind of business logic, joining it to other kind of data set, okay? Start to verify their quality and probably contain intermediate data sets in order to build your trusted and beloved one. So trusted data set, this is where data is really ready to be consumed in public, okay? So it has all the guarantees that I mentioned before, like schema and SLA and completeness, referential integrity, like if I'm going to join it to another table, so do we have the same keys or I'm going to miss some records? Or the data is self-serve, meaning that is easy to be discoverable. It's being built in a maybe read-optimized model for exploration, like a star scheme. It's probably in Parquet file, it denormalized and enriched with all the business logic that I mentioned before. So really ready to be consumed. The way that we chose to organize the relationship between the data set is by using Lakehouse methodology. And Lakehouse is a combination of a data warehouse in a big data ecosystem, the data lake. Okay, so data warehouse, as a bit mentioned before, is a proven methodology for organizing and managing the data for easy exploration and consumption. And also addressing all kind of operational aspect. For example, how to make sure consistency is okay, referential integrity, how to deal with history, and so on. Trusted data sets inside every domain are organized in a star schema. And what it means, star schema contain dimensions. Dimension is business entity states, like job seeker or company or campaigns and so on. And fact table, which are business activities like interaction, clicks, impressions, signals that are being generated by those business entities that I mentioned before, and hence the relationship between them. So there are other kinds of like then dimension and fact tables, but this is the most base and important one. Another thing that is interesting here, you can see that domains are sharing dimension between each other. Like job seeker click on a job, and a job is under the responsibility of employer. So why doing that is because we want to have one representation of a business entity in our data lake, right? So in this way, it's going to be easy to do very complex analysis across all our data sets. All right, okay, so we took a glimpse about the process, okay? Let's discuss a bit about how the org structure can support our vision. So if you remember, we started with teams of specialists, right? Data people team, data scientist team, web team, backend team, SREs team, and so on. So we changed, and it was in one day, we switched to work in squads. And every squad is responsible for a domain. And every squad has all the relevant skills that are needed. This is the full stack that I mentioned before. We have analytics, and we have product, and we have engineers, backend engineers, data engineers, data scientists. Every squad has a well-defined mission statement with well-defined objectives. They are actually owning the roadmap. They are the domain expert of their domain. So at the beginning, some engineers were concerned about this change. I bet that other organizations thinking maybe to move to squads, because many of them actually move for really nice and beloved teams. But early on, engineers, and this is not me saying, started to understand the potentiality of this change, because they started to understand how they're affecting the business and moving the needle. So tech started to care more about business outcomes. And product analytics started to care more about tech debt and potentiality, which is always a struggle. And it also created new opportunities for people, like new teams, new domains, really good stuff. And another thing, it was really easier to collaborate and to communicate because now more teams started to have the same problems and not just unique problem for them. But that's not enough because we also needed SREs teams of specialists with SRE mindset that will focus on building frameworks and services in order to increase the productivity of other teams. So data systems, for example, KRs, are around data and data scientists, productivity, and experience. So this is why we invested in embedding weights and biases tool for easier model training, or unifying our deployment pipeline, or integrating Spark and Data Lake, or Spark with Prometheus, or Data Lake with Glue. All those kind of things that every team now is going to stumble upon. Core infrastructure is a team that its goal is to create, maintain, and operate Kubernetes environments and AWS services at scale in a secure, reliable way with compliances to with all kinds of compliances that are needed. So the question is, are we done yet? Almost, because we also need to help teams to collaborate and to manage cross-team projects. So we also introduce guilds that you heard before. We have MLOps guilds and we have data engineering guilds, and probably they are responsible for guidance about standards, best practices, frameworks that need to be developed and communicate about it. Every engineer that is allocated to a guild need to invest to allocate 20% of their time in order to make an impact. Another thing is that it's a solver team, and here is a data governance solver team. So solver teams are assembly of people that are responsible to manage cross-team projects or a vision. And in this case, the data vision is being managed by the data governance team. So they make sure that everybody are aligned about the vision and the roadmap, and making sure that all the teams and squads are prioritizing their initiatives and KRs accordingly. So some solver team are long-lived, like data vision, maybe forever. Others are short, like upgrading Spark, for example. All right, okay, so we talked about process and structure. Now the next question is, what kind of data engineers we really need? What should be their skills? The theme of it's a combination of Marvel and DC, I guess. So those people are going to be, after all, the agents of change in our organization. So we came up with those three pillars, okay? Data modeling. We want them to be proficient with understanding how to create star scheme and with data warehousing, and how to do data source analysis and requirement gathering and access patterns, how to understand the business and translating it into code, right? Different kind of loading strategies. We also needed those people to be really good with ETL best practices, like how to process bound and unbounded data, how to do a reprocessing, how to manage backfills, how to support schema evolution and product evolution, and so on. And we also wanted those people to be really good and proficient with big data technologies. So it's a really big ask, right? But luckily, we have about 10 people with this relevant skill. But that's not enough, because we understood that we need at least one data engineer to support 5 others. And our organization is like, tech organization is more than 200 people. And we know that we need those people because they will help us to create those empowered, contention-free squads. And that means that we need 50 people. Anybody here try to recruit data engineer? Easy, right? Like, fast. Okay, yeah, it's damn hard, it's slow. The competition is very high. So what should we do? Should we wait for all of them to come? It really can take years. So we homegrown them. We have the knowledge, let's just leverage it. So we took those 10 people and embedded them in every squad. So now every team has at least one expert that is really knowledgeable about our best practices, about our standards, aligned with the vision. Then we started like a shopping spree in the organization. I'm kidding, it was moderated, but we found people with data orientation or will to be data engineers. And then we invested in tens of hours of presentation, standards, about standard, common things, common tools, but in real life, like how to really build dimensions and fact data in the data lake, right, in a consistent way. After all, it's not an ACID compliant, no transaction, it's not our DBMS. How to embed other strategies with append-only files. How to do a processing and reprocessing with Delta Lake and Spark streaming. How to deal with data versioning. How to embed anomaly detection to find problems and drift in the data. Nested column, and so on. And we also used out-of-the-box courses like Coursera about Spark and Scala, for example. Data Guild came into play because they helped to communicate about those standards or just getting all kind of questions from teams and thinking about it. We gave office hours. Data expert helped to team to get immediate answers. We open our design process to be publicly available. So now people can chime in to learn, integrate with what is being done. Retros are really important because then we learn what is not working, which processes are not functioning, which more frameworks need to be developed, or what's not working with them. And we start to organize our wiki for easy discoverability. So especially focusing on onboarding process and how to build data application from end to end. And bam, we move from 10 people to 54 data engineers in 9 months. So of course, not all of them are experts, right? They have different skills, but we have different kinds of tasks. So we can actually match their skills to the tasks that we have and grow them. We also kept recruiting domain experts. But it was easier because everything was much more organized and the onboarding time was really fast. And also think about the retention and aspect of this move, right? So many people got so many skills and it was fantastic. People were very happy about it. Okay, so we covered the process, the structure, domain expert, knowledge. So the last part is the technology. And we have pretty sophisticated stack. It's not all of the stack, but probably many of you have the same, right? Everything is open, mostly. So the question, what we could do in order to support this change management, this vision that I was talking before. Tech-enabled velocity, okay? Let's make things trivial. Let's make things and automate them, okay? Let's take the dirty job out of people. Let's prevent from our data people to stumble upon stupid stuff, which actually means take all those technologies and glue them together to much more joyful and productive and efficient experience. So we took notebooks, for example, and integrated them with all our machine learning and data frameworks on Kubernetes. So now with notebooks, you have all the needed services, and the exploration is fast. We embedded schema registry, so it will be easy to share schema between applications and technologies, and also to support schema evolution. We created wrappers to standardize, automate, and abstract all kind of complexities. So Skates is Spark on Kates, enable us just to launch Spark cluster in seconds, or how to do atomic deploy of data application with DAG deploy, or all kind of like code generators for gRPC or ETF scaffolding and configuration, just bootstrap application without all the complexity that people had to go through, and much more. So probably by now, everybody have the question, where are we today, right? This is the question I see on your face. So the green line represents where we are today, so you can see a big improvement, okay, but a lot of headroom to even get better. So data project throughput has been increased by 5x. We can literally run more things and more complex things in parallel and finalize them, which is important as well. AI model accuracy were improved by 22% because of investment in the data and its accuracy and consistency. Data exploration has been reduced from days to hours, and this is for non-tech people, okay? Analytics now have accessibility to the big data with an easier way. And first call to production, which is a proxy to the onboarding time, has been reduced to less than 7 days. So before I finalize, some takeaways. So first, it's not just about technology. This is why I left it to be the last one. To build the good data culture and organizing the data in a data mesh, you need to invest first in vision and organizational process and structure and best practices, and then understand how to fit your technology stack into it. Second, change management is complex, okay? You have to address multi-layers and all the dimensions that I mentioned, and maybe more of them. Process, structure, experts, knowledge, and technology as well. You have to measure the impact on productivity and business KPIs, because first, you will understand if you're optimizing for the right things, and second, it will help you to prove this investment to your stakeholders. Endurance, okay? Many people here are data engineer. It takes time, and this is like a massive change, so it takes time a lot, okay? It might be frustrating. People might lose faith. You might face all kind of blockers that you didn't foresee, so you have to be prepared for that. So make sure that stakeholders are aligned, products and analytics are with you, and use those KPIs that I mentioned to prove the investment. And the last thing, which is pretty trivial, right? Invest in your people. Okay? Change are creating opportunities for people, but it's also might be concerning. So you have to be transparent and clear and honest about the vision and communicate it well. And you have to address the anxieties of people that people have. You have to teach them, you have to give them tools to grow, and they will gain. Yeah, I forgot the definition of a data mesh, right? So here, I'm going to Google it for you. Okay, straight from Google, put pay attention for the distributed data ownership and domain specific, and data as a product. Okay, now you know, done. So we are here to help. If you have any question about data mesh or how to build data applications or deal with data and an AI at scale, okay, you can ping me, you can ping anyone in Ziprecruiter. We really like to contribute back to the community. And just in time. Thank you so much.